Hello everyone, welcome to the new series on complete guide to Rome. And in this series we will understand what is Rome, how Rome works, and we will do a practical implementation of that for a certain specific project to not only cover the basic CRUD of the local database through Rome, but also understand how complex queries work, how we can write queries to insert or get data from multiple tables through different relationships between those tables. So let's start with the first lecture, and this lecture is about introduction to Rome. So most of the time we see or search on internet through what is Rome database. So actually Rome is itself not a database. Rome is a library which is a wrapper around SQLite to access database to perform different kind of operations. And SQLite is the lightweight version of SQL database, which is targeted to support the database, allow the database support on smaller devices. What benefits Rome provide us are these three benefits. It's provide us the compile time verification of SQL queries. So whatever queries we write to perform different kind of operation on the database, those queries are verified at compile time when we are building our project. So if there is any data type difference or any name of any field is incorrect, then that will be highlighted at compile time. And it also provides us convenient annotations to minimize boilerplate code. So this annotation allows us to do different kind of operation. Let's say if we want to make any field as a primary, then we can use primary key annotation. And if we want to define relationship between tables, then we can use relationship annotations. And there are also a bunch of other annotations which help us to do the migration stuff. And the third step is our streamlined database migration paths. So it help us to do the migration of database more easiest. Migration is a thing, let's say if our app is already live on Play Store, and we are in the next build we are making a specific change which also affect on the existing record which is already stored in the app. So for that we write the migration that whenever any new user is update the app, then the previous data of that user will be migrated and become compatible with the new version of the changes. So we have three primary components in Rome. The first one is database class. Database class that holds the database and serves as the main access point to establish connection with our persisted data. And the second component is data entities. So these entities are represents the table in our database. Let's say if we have a LMS system, then in that we have different entities: students, instructors, courses. So to store a record of each entity, we store that in different table, and that table is defined through data entities. And the data access objects, these are the objects which provide us different methods to query, update, insert or delete data in our database. So if we see the architecture of Rome library, then this is a overview of this Rome library architecture. That let's say if we have our app here, then these are the three components of the room database, actually a room library. So here we have the room database class, which establish our connection with the persisted data and provide us the instance of DAO. So we can get the DAO instance from there, and the data access object DAO provide us the option or allow us to perform different kind of operations on our database. Let's say read, update, delete, or anything else. If we want to fetch data from multiple tables with a specific relationship, then we can get that through this DAO access object. And the entities are representing the tables. So let's say if we have students entity and students entity, and if we are getting a specific student record, then we can get on set the values of that specific student and update that information through data access objects. So this is a brief overview of the architecture of the room. And now let's understand that what data types we have available. So these are the specific data types which are supported in SQLite. So as room library is wrapped around SQLite, so that's why we are understanding that what are the available data types available in SQLite. So in this we have 5 data types to store our data. So although these are limited data types available here because it's a light version of SQL, but these are sufficient for us to fulfill our need on smaller devices. So the first type is null. We can make our any field nullable. Integer is used to store integer values. Obviously we can use assigned integer values, and the value that is stored can be varies based on size. It can be from 0 to 8 bytes, and that bytes are defined based on the magnitude or the capacity of the value which we are storing. And the real data type is used to store floating values, and it take 8 bytes. And the text data type is used to store different kind of strings, and as it's support the encoding of UTF-8 and up to UTF-16 BE and BLE. So it will also support the translation or multi-language strings as well. So let's say if we want to store any string in German, then that can be stored in it. And the fifth type is BLOB, binary large object. So this data type is not quite often we use, but it depends on the need of the app which we are developing. So it is used to store media files or any kind of files in bytes. So we can store, let's say if we have any image or video file or any PDF file, then we can store that file in this type, and that value will be stored in bytes. And whenever we required to read that file, then we can read it from here. And the maximum limit of this type is 2 GB. So we can store that up to 2 GB value in this data type. So there are few scenarios which for those data types are not available, but we have workaround for that. Let's say if we want to store any Boolean value, true or false, so for that we can use integer value. So here is the explanation for that. To store integer values, to store Boolean values, we use integer data type, and in that we represent 0 for false and 1 for true. And in SQLite, SQLite queries, the true or and false keywords are recognized from this version and so on. And the next is date and time. What if we want to store date and time? For that we have three approaches here to store date and time. We can store date and time in text form, in string format, just like this specific format, or we can store the dates in Julian day numbers, which will be a decimal value, so we can store that in real data type. And we can also store the date time in Unix time, so which will be a number of seconds from this date time to the specific date which we want. So we can store that value in the integer data type. So this approach is feasible if the app which we are developing won't have any date before this 1970s. So these are the possible ways to store different kind of values in our SQLite database. And what we next? So now we will set up the ROM library in our project. So for that we will go to this link where we have the required dependencies information, and here is the initial code for this series. You can find the link of this GitHub link of this code from the video description below. So here we need to add this ROM dependency. So we will copy these required dependencies one by one and paste these in our app level Gradle file. We copy these dependencies one by one. So here we copy this one and paste it in our app level Gradle file. So here we will add some spacing between these different kind of dependencies, and now paste our dependency here for ROM. And next one is we need to add this KSP. We will come to this thing later. So paste it in here. And the next is we need to use this Kotlin extension and coroutine support. Okay, so we have our required dependencies which we need for this series. So now we need to add, as this KSP keyword is not recognizable here, so we need to add this KSP plugin. So we need to add this plugin information in our project level Gradle file. And add this line in our app level Gradle file. And one thing that we need to understand that there are different KSP visions, and we need to use that specific vision which Kotlin version we have in our projects. Let's say in our project we have Kotlin 2.0.0. So now we need to add that KSP version which is compatible with this Kotlin version, so which also have been highlighted here. Let's say if we have Kotlin version 2.0.21, then the KSP version must be in this way. So we will go to the KSP GitHub page and here find the specific version which would start with this Kotlin version, so 2.0.0. so we will search here 2.0.0. 0, and as this vision is not available on this page, so we will navigate to the previous page and search it in here. Nothing available here, so move back to the one previous page and search it here, and now we have available this version 2.0.0 and 1.0.24. so we will change it here 24 and sync the project. So we have some error here. Actually, I forgot to make this 2.0.0. So now try again to sync the project with Gradle file. Okay, so our project has been successfully synced with these new dependencies. So to further verify that everything would be synced perfectly and will be work as expected, we need to run our project. So as our this app initial app is working successfully without any error, so that means we have successfully added Rome library in our project. So this is it for today's video. So I hope this would be meaningful information for you, and in this series you will be able to understand these Rome concepts in a better way. So I hope this would be a meaningful information for you. So thank you for watching. Bye.